My name is Jonathan Ulysses Marino Carr. I'm a single father, been that way 5 years. Alright, I think why I know this stuff is because I have a very good perception for abstract thought, analytical thinking, and logic. And I think it had to do with when I had an accident, car accident, and it affected my prefrontal cortex, and it allows me to know this stuff. I don't know why I know this stuff, but I understand fundamental physics, quantum mechanics, and all that stuff. Literally, I can see how every bit of it works in my head. I can understand every particle, why it interacts the way it does, and how it does it. I don't know why I understand this stuff, but I can see how every bit of it works in my head, and I'm going to explain every bit of it. The theory of everything is the key to the microverse. Believe it or not. It's the key to the unicosm. Alright, now, consider Heisenberg energy, 0-point energy. Now, Heisenberg was behind in the nuclear arms race, alright? But it seems to me, with everything I've figured out, Heisenberg was focusing more on 0-point energy, okay? Which is basically nuclear fusion. He was focusing more on fusion. Everything I've found out about his research leads me to fusion, not nuclear destruction. Okay, so you have these point particles that flop in and out of existence. Okay, these point particles are basically micro supernovas. Okay, they're micro supernovas. Okay, now this energy wants to go to a lower state, and as fast as it flashed in a split second, in relativity to space, it was a stellar evolution, which lasted millions of years in its relativity, on a micro relativity. Okay, there are cosms in the universe and subcosms, okay? I'll get to those, all right? Space is static infinite, okay? It's nothing but a soup of electrons, basically. That's all it is, all right? E equals mc squared, okay? Basically, in the universe, when you have nothing, there is still 0-point energy, Heisenberg energy there, okay? Like I said, Heisenberg seems to be, was on the trail of fusion rather than splitting them, all right? Now, you have potential for occurrence and microoccurrence. Now, I've applied a lot of my own terms to a lot of this stuff, too, to make it make sense, because it's problems that we don't know in science. Okay, so you have your potential for occurrence and microoccurrence, all right? And static space has no beginning and no end. So time is irrelevant. You cannot put time on space, okay? Space has to exist. How do you have a Big Bang if space didn't exist yet? This is all we get. Where's the rest of it? See what I'm saying? If you have static infinite space, this is going to go out everywhere. And this means there is a center of the universe. Where's the rest of it? Why would they do this? Why would they say it's expanding? We see only the matter flying out. That's momentum. That dark energy is the momentum from the Big Bang. With everything I've found out, it's almost like they're fooling everybody. There's a veil over everyone's eyes. There, look at this. Even this depiction. Space keeps going, okay? Imagine this is the Big Bang, or a star, or a point particle. They all are the same thing, but on different cosms, okay? This thing is literally going to go out in every direction, because all of this space exists. It has to exist. You cannot have a singularity if there's no existence for it to exist. See what I'm saying? This singularity came from the plasma of the universe. Okay? It explains leptons and quarks. Now, since time is irrelevant and we don't know where the rest of space is, according to the Big Bang theory that Einstein talks about, now if we can only get to more of leaning toward Heisenberg in my own research, maybe we'll find out the truth. Now, these point particles are micronovas, quark nova, microstars that want to exist as quarks, okay, or as microplanets, all right? But these quarks only pop in and out of existence, all right? Now, they want to exist as matter, and as much energy that they put out in exploding in that split second is enough energy to convert into a lower matter and last forever. See what I'm saying? The cosm changes, all right? So this will explain why quarks act the way they do. All right. So in that stellar evolution was basically a microsecond, and that's a point particle relative to us. Relativity is a very big factor here. Okay, and there's special relativity and even more special relativity. All right. Now, a star wants to reduce to its lowest form, which is matter. quarks, up quark, and down quark. All right. So this is my theoretical particle. All right. We think that preons make up quarks and down quarks. Now, to be able to have two of them, you'd have to have another element there, or a particle, and I call them zeons. I pretty much put this as a hydrogen and helium, and they both make a microstar, which is a quark, or which is a quark nova, okay? Which ends up creating more neon, or preon and xeon, which forms itself. And when you pull a quark apart, you're basically grabbing a planet and pulling it apart. And that energy you put into that planet, tearing that planet apart, is going to create preon and xeon. And that xeon is going to form another quark in the closest relativity to it. No matter how far or how close you are to that quark, the closest relativity on a micro scale is still right next to it, that preon and xeon that's ejected, which will spontaneously make another quark. Okay? This explains the nature of quarks. They are the positive charge in the universe. Okay? They're the quark material of the universe. They're the nuclear energy of the universe. Okay? That's what they are. They're the micronuclear energy of the universe. And in that micronuclear energy, you're going to have ethereal negative energy. Okay? You have to have the negative energy. There's a positive and a negative. So basically a quark forms. It's like a microplanet that can coalesce like planets do or matter does in space. See, it coalesces. All right? All right, so these quarks, up quark and down quark is all you got. All right? And what they do is they make protons and neutrons all over the universe. I mean, all these little spots flicker. Look at a TV and imagine on static channel, all those little black and white dots that you see. Imagine that's the universe and these quarks popping in and out of existence. And all of that static is flickering basically into matter. It's a microverse. It's plasma. It's a protoverse is what it is. And I'll get to that too. It's a protoverse. It's plasma. The scales keep getting bigger. Nothing new happens in space. It only happens on a grander and grander and grander scale. Now we see this and know this, but when we see this grander scale, we never actually put it together. When we see this grander scale in nature, we always say, yeah, that's crazy how a nebula looks like a pupil, or a solar system looks like an atom. This is why. Like I said, it's the theory of everything. This is the key to the microverse. Okay, so you have the positive energy, which is the quarks, the little micronovas, and then you have the negative energy, which is the electrons all over the universe, the static. So you have the positive and the negative, staticky, all over the universe. The leptons and their generation, they are all created from the etherical plane, and all the quarks in their generations are created from the nuclear plane. See what I'm saying? You always have a nuclear DNA, and you have a mitochondrial DNA. Even the universe starts with plasma, okay? And it's like mitochondrial DNA and nuclear DNA. You have your nuclear, which is protons and neutrons. Then you have your electrons, which is the mitochondrial. All right? Now, this is the strong force. These protons all over the universe. See, these electrons do not have a strong interaction. All right? So they're going to only be loose with these protons and neutrons. They're not going to interact with the protons because of the neutron. All right? They're not going to explode. What they're going to do is lay loose. They're going to stay plasma, soupy plasma. Okay? Now, once all this soupy plasma and this strong force creates all over the universe, all right, there's electrostatic already, okay? But gravitons at a charge of, or a gravity range of 0.015 or 0.15. Now, the reason why our gravity, I'm going to explain the gravity, but one problem with our gravity is we do not apply for microgravity. There is microfractional gravity involved here, okay? And that's one problem with our gravity. And I'm going to explain the whole correlating matter with the gravity because it's very, very insane the way this works. Okay, so now you got the soupy plasma all over the universe that just came from this static. And these popping in and out of existence. These protons and neutrons and electrons are just soupy all over the universe. Okay. Now they start to come together. The gravitons start pulling these together. Gravitons are microgravity. That microgravity, I've applied 0.15. All right. Now that microgravity pulls everything together. Okay. And like I said, you always have your this is a micronuclear DNA or micronuclear energy. All right. This is your strong force. Now that you have this, these gravitons help create this weak force around it. And that's where all the electrons in the universe are. So now you have all the electrons in the universe, and you have all the protons and all the neutrons in the universe. Okay, now you're going to have electromagnetism. Okay, electrostatic only existed first because there wasn't no unity. It was basically standing or sitting static. It was resting static. Now you have electromagnetism. You can put the electrons in a current somehow and create an energy flow of them. So now the strong force is created, the weak force is created, gravitons, which start to form gravity, and then you have your electromagnetism. So now you have all four fundamental forces of nature. The fifth one is where it all began, plasma, which is also the fourth state of matter and the fifth element, believe it or not. Now, I've applied the strong force here at 0.35. All right? You have the strong force at 0.5. Then you have your microgravity, 0.15. All of these equal 1 g of fundamental gravity. So now, once this all comes together, you have 1 g gravity that's finally been broke through on our fundamental level of relativity. Now our fundamental relativity can begin. All right? And you have the gravitons, which have grown from this number to 1.85, which is 2 g's. So now you have 2 g's of gravity, the weight of the Big Bang. Okay? Believe it or not, the weight of this Big Bang, that is the God particle. The Big Bang is the God particle. It is what created everything in the universe. It's what gave mass to everything in the universe. It's what every bit of matter is made of. We know this. I don't know why they suppress this. It seems like it's a joke and we're being made fun of or something. I don't know. I start to think it has to do with religion, but I just don't know. But look, you have your first, second, and third gen of matter. Okay? See, the first generation of matter is basically the preons and xeons, which make up the spark, the mini supernova. Okay? The quarks. Okay? The point particles that are microstars. Microstellar lifetime. They live a microstellar lifetime. Okay? These quarks make protons and neutrons. Okay? This is the first generation of matter. Okay? And then you, of course, have your lepton material, which is the static. I call it, it's the page. The page is basically space, and it's static energy. Even if you rub it, you'll get static, okay? That explains enough. Even that correlation tells us that the universe is static, okay? So you have electrons and protons and neutrons, and it's in soupy energy, okay? And all that soupiness is the second. This is the second generation of matter, which forms. This is the section where it forms and blows up eventually, all right? Now, even if it's just a single second, a Planck second, that is basically a stellar evolution, all right, compared to universe. To the universe, literally, anything that lasts 1 second to 1 billion years all lasts just a split second. See what I'm saying? In relative to empty, infinite space. Okay, only the matter in the universe is expanding. The universe itself isn't. So basically, you have your point particles, you have your quarks, hadrons, singularity, and everything. That's the fourth state of matter. Okay? The second and third states of matter. Okay? The leptons and quarks. Okay? Then you have, when this forms, the strange and charm top and bottom, tau neutrino, muon neutrino, all of these are going to be formed here, okay, in the Big Bang, in basically this quantum evolved star. Now, this is all technical stuff, all right? And this is where the hydrogen isotopes will end up coming from. Basically, this is how space is. Imagine it being just a fabric, okay, and it's just like a wavy ocean of just literally dark matter, which is static. Static electrons, tau electrons, anything that is a lepton is existing in the ether. Any lepton exists in the ether, and it exists outside of an electron. Out. See what I'm saying? Electron shell, out. Anything from a lepton is there, out. Anything from a quark is there, in. See what I'm saying? And some of them won't react with electromagnetism because they formed before electromagnetism was even formed. Or I'm wanting to relate this, as a matter of fact, this makes more sense, is the fact that they are formed from electromagnetism. And that's why they won't react with electromagnetism. Okay, see, leptons only exist in the ether, in the ethereal plane, and these all exist on the nuclear plane. This is basically nuclear DNA, mitochondrial DNA. It's always binary. That's why everything always looks the same. It starts out tiny and looks like this, ends up tiny and looks like this, but on a gigantic scale in relativity. See, the Big Bang happens, lithium, hydrogen, and helium are dispersed all over the universe, okay? And this is where fundamental gravity can finally take place. And this is the fourth state of matter. This is everything that exists. It's the fourth state of matter. Everything that we know as matter that exists in molecules, in molecular form, is the fourth generation of matter, molecules. It's galaxies, planets. See how everything always is a sphere? Okay? It always starts with a circle. See? You have your strong and your weak force, which is a proton and electron, or it's a strong force, which is a sun, and a weak force, which is a planet, or it's a strong force, which is a planet, a weak force, which is a moon, a strong force, which is a moon, weak force, which is a submoon, galactic nuclei, which is a strong force, the debris, planets, stars, moons, everything else, that's the weak force. Okay? See? No matter how big you get, you always have the same forces applying, just on a different scale. So the string theory is proved with the plasma from the universe, with the protoplasma of just straight electrons, neutrons, and protons. All right? The dark matter is basically all the electrons in the universe, and that's why our electronic tools don't work. The dark energy is the dark nuclear energy that was spread out all over the universe, which is the nuclear energy of like a black holes. It's the microgravity, okay? That's what black holes are. They're like the microgravity of a nucleus. It's the strong force that holds a nucleus together. The proton spin crisis is because a lot of these quarks, there are actually micro fractional charges that we're not applying. Our fundamental numbers that we use can't apply to them. We have to find another way to transition our fundamental numbers into micro numbers. See? Because of these fractional, these micro fractional. I mean, these are points. And that's why we're getting different spins of protons in a lot of cases, which we think that they should act the same way and spin the same. But if you have quarks that have different microfractional charges or spins to them, then you're going to get protons that spin different speeds, basically, and have different momentum to them. All right, now black holes. I'm going to explain why light doesn't work in a black hole. I'm going to use the God particle or the stellar supernova as an example. Okay, we need electron microscopes to see this small. All right, we need electron microscopes. Light cannot get this far down. All right, that's why black holes suck up all the light, because literally light cannot penetrate through that strong force. They cannot see that small. That's why, because we need electron microscopes to see that far. If we want to look into a black hole, we're literally going to have to use like an electron microscope. Exactly. We're going to have to use electrons to see that, and we're going to have to use whatever this strong energy is, if we could ever harness it, to see what happens in dark matter clouds, basically. They coincide with each other, and most likely that's what's going to have to be our instruments. All right, so it solves the God particle. Okay, it all begins with plasma, and it all ends with plasma. And there's nuclear fusion. Okay, this is how everything came together, but I'll explain how I understand nuclear fusion and why they can't get the Potomac and all these other ones working. This is string theory. This is what the primordial universe looks like, just static and filaments and plasma. Okay, this is what the beginning looks like, and this is when we get to the macrocosm. Okay, there will be a unicosm inside this plasma. Basically, there's another, it's a macroverse. See what I'm saying? This is the end. It starts that way and it ends that way. You start out in a protoverse that has a protocosm. Okay? Basically, relativity flips inside out every time. See, when you get to, I'm just going to go with the microverse. Now, we know what the microverse is, or a microcosm. That's what we see as particles, subatomic particles, or at least fundamental particles. These are subatomic particles. We see these as microparticles, okay? Then there's nanoparticles. When we get to our universe, we're going to have a micro-subcosm, and that's exactly what we have. A subcosm is what everything in that universe is made of, all right? So everything that's matter in that subcosm is made up of what this was as a verse, as a microverse. Everything on a large scale will become a small scale here. And then when this flips, everything on a small scale will become a large scale. See what I'm saying? It all flips, okay? Here we have protoatoms. Here we have nanoatoms. Here we have microatoms. Here we have regular atoms, because that's our verse. That's our cosm. That's the unicosm or the nutricosm that we live in. And then there's plasma again in this macroverse. That is this, the universe. Bolshoi and out. That's the macroverse. From this down to an electron is basically covers the unicosm. Anything below that is in a microcosm. Anything below that is in a subprotocosm. And then you have your protoverse and your nanoverse, or say a nanoverse and all that. Basically, you see what I'm saying. Everything becomes something bigger, but on a small fundamental relativity scale, it flips. So a point particle, we found out, has the exact same properties of a supernova because they have no relativity in space. And E equals mc squared. So all of the energy of these sparks and particles you have all over the universe, these little mini micronovas, are giving energy to the universe, basically, that end up turning into matter. Because everything wants to exist, and it has to exist in its lowest energy state, or it's not going to live long. It's not going to live long. And that's why on this microcosm here, these quarks, when they flash, they have this micronova and turn into basically planets or quarks. They're microplanets. Quarks are microplanets, which become bigger microplanets or protons. Now, I might have the relativity off just a little bit. I might have to do a little bit more research to exactly match it up. But this is the key to understanding all of this, okay? This right here will get everyone, I hope. I just ask that people share this and get it around, because I know this will change our understanding of the universe. This will literally change our understandings of the universe. This will give us a whole new era. It will definitely give us fusion technology, and I'm about to explain fusion. Now, like I said, this microcosm has quarks and leptons. You have the positive energy or the nuclear energy, which are quarks. You always have that on every fundamental level, all right? And then leptons, which is the ethereal plasma or mitochondrial, nuclear, mitochondrial. Everything's binary. And like I said about with gravity, all right, you have the strong force 0.5. Now these are the integers that I applied, all right, to basically make it make sense, to understand how it makes sense, to relate how it makes sense. Okay, then you have your weak force 0.35. You have your gravitons. These equal 1g. All of this energy, all of these forces here, all of these pull-togethers added up are what our gravity is. Okay, our fundamental gravity. You have to have all of these forces to create our fundamental gravity. All right? You do not need the electromagnetism, but electromagnetism can, on our plane, substitute as gravity on Earth. We can't use gravity because of our planet, but we can substitute electromagnetism for it. And that's why you can trade that off. And that's one reason that, like tau muon, I think it's in tau muons. That's why the muons, muon neutrinos, tau and tau neutrinos don't interact with electromagnetism, because these are actually pretty much created in the ether from this cosmic atmosphere. Okay, these other generations of leptons are created in this outer shell, in the electromagnetism. That's why they don't react to electromagnetism, because that's pretty much kind of what birthed them. You know what I'm saying? So if something originates or births something, if we use something that uses that kind of power, then we can't see it. We won't be able to see it. We'll have to use one of the other forces to identify it. See what I'm saying? Like I said, it started out plasma. This is when you get to the micro, fundamental plasma of the universe, which is static. Because all you have to do is know that the universe has existed forever, and only time and matter are symbiotic. It goes space, comma, matter, and time. Time only applies to matter. Explodes. The matter is going to exist, but it doesn't exist as we know it yet. So you can't apply time until it explodes and turns into fundamental matter, and then you can apply time to it. That means space came first and originally existed forever. Then matter formed, exploded, now you have time. See, this explains why it remains in a plasma state. All right, in this micro scale, in this interstellar medium, all of this static is not going to interact with these positives. Now, if you take a proton and an electron, they're going to spark. They're going to blow up. They're going to explode if they touch each other. But if you have a neutron canceling it out, all they're going to do is be soupy. It's not even going to orbit it yet. What it's going to do is be like a soupy mixture, like a cocktail mix of protons and neutrons hooked up with electrons hanging around them. You know what I'm saying? You're going to have the nucleus and the mitochondrial DNA. You're going to have the sperm, and you're going to have the egg. Basically, that's the only way I can relate it, okay? It even relates on a fundamental scale. That's why whenever we zoom in and see this stuff inside nucleus, zygotes and stuff like that, that's why our zygotes of humans are, freaking in the uterus, all looks like this stuff here, all like space, because of this cosm, these cosms here. So we know that micro occurrence can create plasma. We know this. This. Look, I'm not adding anything. Basically, right here, I'm not adding anything. We know this stuff. The only reason I broke it down further is because it further makes more sense. There's further connections. If I keep it simple, if you have just protons, just neutrons, just electrons, you'll have just plasma. And it's going to look just like this. It's going to be these filaments. It's going to start with that, and then when we get out so far and see what we see of the universe, that's what we see. The same thing happening over again. I just like the sound quantum evolved proto-nucleonic star. That's basically what the God particle is. The Big Bang, That's basically what it is. That you cannot deny that. If you try to deny that, there's something wrong. I don't know why science is just laughing at us. I don't know why. I don't know why they did this. I don't know if they were trying to wait for somebody to come along and solve it. And I wish this would give me the Nobel Prize. That would give my kids such a good life. I mean, like I said, I'm a single dad. Been that way 5 years. It's tough to make ends meet, And I just really want some kind of recognition to be able to give the kids a really good life. Because I didn't have that. But I've always been obsessed with this stuff. It applies to E equals mc squared, Heisenberg energy, everything that Heisenberg was talking about, some of what Einstein was talking about, but of course you have to have the rest of it, okay? The rest of it. That means space had to exist first. It had to. This is not something you can just theorize. Literally, fundamental time cannot apply to infinite space with no beginning and no end. That's as simple as it gets. Simpler than that, the only thing that can occur, it's not space-time. It's potential for occurrence and micro-potential. That's what exists in space. Then, time and matter. Well, matter comes before time. And like I said, relativity flips inside out. It literally flips inside out in every cosm. So whenever you have all of those nuclear energies and all those nuclear things happen, created one gigantic nuclear particle. Because the Big Bang, literally in infinite space, could be literally bigger than our local group of galaxies. But in correlation, that's correlation to us, but correlation to space, it's a dot. It can last billions of years to us, but only a split second to space. Or it can last only a split second to us and Planck seconds to space. See what I'm saying? This is why relativity is special here. This is special relativity, and this is how relativity flips inside out every time a verse or a cosm is born. So this quantum evolved star, or the Big Bang happens, it blows up. Now, all of that weight and strong energy in it is going to form black holes. Okay, all that weight and stuff was still there. All that weight that it pretty much weighed, it doubled gravity. Okay, fundamental gravity eventually formed. But the weight of this was so huge because it was literally everything in the universe and all the strong energy, the strong gravitons and strong forces, that when it exploded, that's what it sent all over the universe. Pieces of strong force, pieces of weak force, pieces of fundamental gravity, which it involves them, and electromagnetism. Okay, electromagnetism is like a byproduct, and that's why in lighter particles, it's either non-existent, or when they coincide with the ether, they're non-existent. Leptons hardly, the only one that even reacts with electricity or electromagnetism is electron. The rest of the leptons do not react with electromagnetism. That's because they are ethereal particles. They're ethereal particles. They're created out here in the electromagnetism. Therefore, they're not going to react with the electromagnetism. See what I'm saying? When we think, we got to think backwards at the same time. I know it's confusing, but this literally is the key. This is the key. This is the theory of everything. Like I said, you have the potential for occurrence and micro potential. That's all you have. This micro matter here is is basically what dark matter is, or not dark matter, but the strong force, the gravitons. So all of those gravitons that ended up reaching two gravity masses are all expelled in the universe, and then we only end up with one gravity mass, which is fundamental gravity. But that fundamental gravity is basically what we have inside these in microgravity. This is what holds the nucleus together. This is the strong force. This is patches of strong force. And like I said, light cannot see the nucleus. We can't pass it that far in our microscopes. We have to use electron microscopes to see that far. That's why light will not pass through, or light does not interact with a black hole. That's why a black hole sucks it up. Imagine trying to use light to see into a proton or a nucleus. The light's gonna get sucked up. It's gonna end up disappearing, right? Because we cannot see that far. The particles for light get too big to see that far. The same kind of reverse principle happens here. It's an advancing principle, but it reduces. Everything in the universe advances and evolves, but it reduces as it does. It flips inside out. Relativity flips inside out. That's the reducing as it evolves. See what I'm saying? It's kind of confusing, but that's why I drew it all out and explained it all out like this. Philosophically. Philosophy can solve anything. You don't need math, because a lot of people don't understand it. Now, I can do a lot of it, but I've lost a lot of steps because, I don't do that in my life. I have a different job. So if you don't use it, you lose it. You have to understand how physics work. So like I said, you have a strong force and a weak force. Your positive and negative. Your protonic or nuclear energy and your ethereal energy. Your nuclear DNA, your mitochondrial DNA. A sun, a planet, which is the covalent radius. The covalent radius where electrons would orbit is a covalent gravity here. It's like it's an ethereal covalent bond. That's what an orbit is. It's an ethereal covalent bond. It happens in space on a grand scale, but it also happens on a micro scale. But the micro scale and the grand scale, the relativity is different. You have different kind of relativity, but it's the exact same thing happening. See, you have a planet, you have a moon. That's the covalent radius, where that can orbit at. That's where an electron is going to orbit if it's a nucleus. It all starts basically the same thing. It's always a dot or a point, and then it all just gets bigger. Everything just grows bigger in a circle. See? Say this is a planet, and this is a moon, this is a submoon. or this is a moon, and then there's or this is a sun, this is a planet, this is a moon, and then there's a submoon on it. See? See, in the universe, you only got that soupy static, that plasma. That's the string theory. And when you add up all the forces, you're going to get the gravity. But when it's as a big bang, as the God particle, this gravity is multiplied times 2. Okay, you got 2 times the energy here, because you got all of these forces added up, and finally fundamental gravity. But that fundamental gravity, because of all those gravitons that pulled these subatomic particles together in the microgravity, is going to grow bigger and bigger and bigger from microgravity into the giant gravitons, or the weight. The gravitons start micro and they grow to 2 times the massive energy. Okay, when it explodes and gives mass, to the universe, then you lose that graviton energy, and you only get the single 1g instead of 2 g's, because all of that gravity, all of that weight was distributed all across the universe. See, and when it explodes, it loses that graviton energy. It loses it. And now the graviton energy is no more. It's dispersed all over the universe with the strong force, the weak force, gravity, and electromagnetism. And gravity is basically a combination, because it's fractional, microfractional. And those microfractionals are the strong force and the weak force. Okay, so a point particle lasts just a split second. The God particle lasts only a split second. All right? The point particle. But it's only on a grander scale, that's all. It's a interstellar. This is the Big Bang that we got. This is the Big Bang that really existed. Where's the rest of it? There's the rest. This is the theory of everything. There's the rest of it. All right here. Static universe existed. Why would they change it if they already knew? They were hiding something. Oh, it's a static universe. No, don't say that. That's what it seems like. All right? See, you have your 0-point energy, which makes quarks, or is quarks. These quarks are hadrons. They end up making hadrons up and down. Their relativity to each other will end up producing this primordial plasma that they all exist in, which ends up coalescing. Of course, in this process, you're going to get the first, second, and third generations of matter. Then once this Big Bang, this God particle, goes off, you're going to have the 4th generation of matter and everything in the universe. There is a center of the universe. When we look back in time, we're looking back into a macroverse, basically, or another microverse. Okay, now if infinite static, say this is static universe, it's just plasma, okay, and it just exists forever. This point particle that came into existence can happen everywhere, on even a bigger scale, because static infinite space, you know? You have a Big Bang here, way over here, you have another Big Bang, but this is a galaxy, and there's going to be a galaxy here, but these are so far apart it's unimaginable, you know? These are universes that are so far apart, they're unimaginable. I mean, even our whole universe, the plasma we see, is just a tiny little dot sector compared to this open space in between these Big Bangs. We have to think big. This brings us to the microcosm. Like I said, the universe is binary, all right? And we also get a fairly even distribution of gravities. It's because the center of the universe distributed everything out like an explosion, like Big Bang. But the fabric of existence had to exist first. Space, or this page, had to exist, or I couldn't draw a Big Bang on it. The Big Bang couldn't be drawn in space if space didn't exist. That explains where the rest of everything is. And this is the theory of everything. And relativity is a big, important factor here. It's a very big and tiny important factor, because relativity only exists on certain planes, on cosms, okay? If you're on a cosm, then you have relativity. But if you are talking about or trying to understand a different cosm, your relativity does not apply. So we know that a split second can be still a stellar evolution, billions of years compared to space, or a split second compared to space. Doesn't matter. We see these dots and sparkles in space all the time. They're called supernova. It just happens on a smaller scale, a micro scale. And like I said, it seems that Heisenberg understood fusion better than he understood splitting atoms. He understood them because this is all I've been obsessed with, and it's led me into everything that Heisenberg literally. This has been my theory, and it led me into Heisenberg, and everything that he theorized is everything that I know about physics and nuclear fusion and how the universe works instead. But we have to get past this point of nothing existed. We have to understand that the universe is infinite, static, and it is only one plane of existence. One plane of existence where only two things can happen: potential for occurrence and micro occurrence. Now, this is why I theorized the Xeon, okay? Now, we think that quarks are made of preons, all right? It's like a hypothetical particle. Well, in order to have two of them, up and a down, you need two of these, okay? You need two elements to be able to have an up and a down. If you only have everything made of one element, you're only going to get one quark. So I theorized the particle is Xeon, preon and Xeon. An up quark is two preons and one Xeon. A down quark is one preon and two Xeons. A proton is 4 Xeons, 5 preons. A neutron is 5 Xeons and 4 preons. See what I'm saying? This is where 369 comes into hand, because you have 3 of them, and you have 6 of them, which will make a particle, and you have 9 inside each. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is how the universe comes together in this 369 mode. Don't let that fool you. 369 also coincides with cold fusion. And if you watch any of my other videos, I explain cold fusion. Look, this is why I'm just so obsessed. I've been obsessed with this for years. And the reason it explains cold fusion is because it's the creation of the universe and plasma. And that's exactly what you're doing in cold fusion. You're creating a star. Okay, that's why these tokamaks they can't get these things working. Ever since I've been uploading my videos, every country's got one now. When everybody always gave me crap about it, cold fusion's a myth, you can't do it, yada yada yada. But I knew it can be done, and I was persistent and kept putting my videos up, and it led me to all this, and verified that it can be done. And now they're trying to do it, and they can't get them working, and I'll explain why. Check this out. This is the universe. This is the rest of it. This is the theory of everything. The rest of it. Here's the Big Bang. Doesn't it look like Pac-Man? Like I said, it's almost like they're laughing at us. See? Your Big Bang, boom, there's the center of the universe. It starts plasma, and it ends as plasma. The further out you go. And if you zoom out and zoom out and zoom out, like at the end of Men in Black, where the universe zoomed out and all of a sudden it was a little marble, that's real. This is the microverse. Okay? This is the introduction to the microverse. That is real. Okay? Don't think just because it was in a movie that it can't be real. Alright, now here's the fusion process. Okay, this is a quick and easy reason why they cannot get these stars to keep burning when they create them. They get magnetic islands in the plasma and all that. Okay, first of all, when you have space and you have a star, all of this energy is being distributed out into space. Okay, so once it starts fusing, it's letting off energy. Alright? You cannot cage a star. You can only harness it. Alright? So whenever they do this, all of that energy that it's producing is being caged up and burning out. They're smothering the star. They're killing it. They need to hook this up to a thermoelectric generator with semiconductor diodes using 369. 3, lithium. 6, carbon, fluorine, 9. The electronegativity, this is basically a thermonuclear equilibrium here to be able to maintain a star and plasma. Alright? Now, the more I've been researching this, I found out that I had these backwards. The alpha particles are actually the strong interaction, the helium-4 nuclei. Okay? The weak interaction is the ethereal plane. Okay? You need your nuclear reaction, which is the nuclear energy. Okay? Then you have to have your ethereal plane, which is your weak energy. Alright? Like I said, mitochondrial, nuclear, DNA. Okay? This is the weak force. Alright? Now, electromagnetism creates gravity. Okay? We use it to be able to compress this into a field and create it. It'll end up forming lithium. But these semiconductors, we use radium. Okay, this is what I've came up with from all the research. This capacitor, the Ark of the Covenant, was a radioisotope thermoelectric generator with an open arc. Okay? It had a positive and a negative. It had an anode and a cathode, alpha and omega. Alright? This is God particle. This is star. Just like I said here, this is the God particle. This is why. It's the pyramid. It goes in here, okay? It goes in here. This is a giant thermoelectric generator. It uses star heat. You have a hot chamber and a cold chamber, like I said, using the Seebeck effect. My phone's getting hot. Okay, now I understand the unifying. You got to unify your fields, and you get the cold fusion. Okay, it's got to go inside a thermoelectric generator so you can sweep off this energy. Once it starts fluxing, there's a free flux going on. In space, this is called a free flux because as it fuses, it emits energy. It's always emitting energy as it fuses. That's a free flux. You cannot cage that energy, that free flux. You suffocate it. Okay? That's why they can't get them to work, because you cannot cage it. You have to hook it up to a thermoelectric generator to sweep off that energy, or you're going to smother the star. You're going to kill it. You're going to have a magnetic island build up. You're going to have a plasma island build up. You're going to have the exact problems that they're having. Now, like I said, I broke this down all philosophically and explained the God particle, cold fusion, which is the Ark of the Covenant, which is a star, okay? God particle that coincides with the God particle here. That is the Big Bang, all right? How to create a star, how everything came into existence from static energy and nuclear energy. You have the nuclear, the mitochondrial. That's how it starts. Now, instead of a mathematical equation, I pretty much put this is how it works, okay? When you're splitting an atom, all right, this way, you have to maintain, it's maintaining stable energy, stored stable energy, maintaining its existence, all right? You have to split it, you get energy. You release, and it's unstable. So you have stable, unstable. Stored energy, you split it, which creates more energy, and you release that energy. In fusion, it's the exact opposite. It's backwards. You have maintain the existence, okay? And it's stable, all right? It's stored energy. You fuse the energy, you get energy, all right? And when you fuse this, and it's unstable, release. That's the exact same thing you get here. When you look at fusion, which is reverse, see what I'm saying? Split forward, in fusion, reverse. It seems like it should go the opposite way around. But that's the whole point in getting fusion and splitting them confused, because there's a microcosm and a macrocosm. And whenever something evolves, it reduces, okay? The relativity flips inside out. That's the whole point here. So when you're fusing, this is in reverse. You have unstable particles, and you release them, okay? They fuse, creating energy. It's stable and stored, and you have to maintain its existence. See what I'm saying? You cannot cage a star. And this is why the God particle relates to the Ark of the Covenant, which relates to thermoelectric generators, which relates to the pyramids of Giza, which relates to the theory of everything. And this is all the theory of everything. If you have any questions, let me know. Sorry about this being so long and cut up into so many videos. But if you like this, please share. I'm trying to get this out. This will change our whole world. And that's all I've ever wanted to do. That's all I've ever wanted to do in my life, is try to make the world a better place. I don't know if identifying the God particle is going to do that. I don't know. They had to have suppressed it for a reason. I hope I don't screw that whole plan up, because there's always a lie or always a plan. I don't want to do that. But if this helps science and helps our understanding and helps to make the world a better place, that's all I want to do. But this is special relativity. This is the key to the microverse. This is literally the theory of how everything came into existence, and the God particle. And it also solves a lot of astrophysical questions that we have, and a lot of things that we didn't understand, but this puts them into perspective. Cold chamber, like I said, using the Seebeck effect. My phone's getting hot. Okay, now I understand you got to unify your fields, and you get the cold fusion, okay? It's got to go inside a thermoelectric generator so you can sweep off this energy. Once it starts fluxing, there's a free flux going on. In space, this is called a free flux because as it fuses, it emits energy. It's always emitting energy as it fuses. That's a free flux. You cannot cage that energy, that free flux. You suffocate it, okay? That's why they can't get them to work, because you cannot cage it. You have to hook it up to a thermoelectric generator to sweep off that energy, or you're going to smother the star. You're going to kill it. You're going to have a magnetic island build up. You're going to have a plasma island build up. You're going to have the exact problems that they're having. Now, like I said, I broke this down all philosophically and explained the God particle, cold fusion, which is the Ark of the Covenant, which is a star, okay? God particle that coincides with the God particle here. That is the Big Bang, All right, how to create a star, how everything came into existence from static energy and nuclear energy. You have the nuclear, the mitochondrial. That's how it starts. Now, instead of a mathematical equation, I pretty much put this is how it works. Okay, when you're splitting an atom, all right, this way, you have to maintain, it's maintaining stable energy, stored stable energy, maintaining its existence. All right, you have to split it, you get energy. You release, and it's unstable. So you have stable, unstable. Stored energy, you split it, which creates more energy, and you release that energy. In fusion, it's the exact opposite. It's backwards. You have maintain the existence, okay? And it's stable, all right? It's stored energy. You fuse the energy, you get energy, all right? When you fuse this, and it's unstable, release. That's the exact same thing you get here. When you look at fusion, which is reverse, see what I'm saying? Split forward, in fusion, reverse. It seems like it should go the opposite way around. But that's the whole point in getting fusion and splitting them confused. Because there's a microcosm and a macrocosm. And whenever something evolves, it reduces. Okay? The relativity flips inside out. That's the whole point here. So when you're fusing, this is in reverse. You have unstable particles, and you release them, okay? They fuse, creating energy. It's stable and stored, and you have to maintain its existence. See what I'm saying? You cannot cage a star. And this is why the God particle relates to the Ark of the Covenant, which relates to thermoelectric generators, which relates to the pyramids of Giza, which relates to the theory of everything. And this is all the theory of everything. If you have any questions, let me know. Sorry about this being so long and cut up into so many videos. But if you like this, please share. I'm trying to get this out. This will change our whole world. And that's all I've ever wanted to do. That's all I've ever wanted to do in my life, is try to make the world a better place. I don't know if identifying the God particle is going to do that. I don't know. They had to have suppressed it for a reason. I hope I don't screw that whole plan up, because there's always a lie or always a plan. I don't want to do that. But if this helps science and helps our understanding and helps to make the world a better place, that's all I want to do. But this is special relativity. This is the key to the microverse. This is literally the theory of how everything came into existence and the God particle. And it also solves a lot of astrophysical questions that we have and a lot of things that we didn't understand, but this puts them into perspective. My name is Jonathan Ulysses Marino Carr, and I identified the God particle. The Higgs boson has the singularity that created everything. The universe has only one plane of existence. In that plane of existence, only potential for occurrence and micro-occurrence or micro-potential can happen. And that is a microverse that creates the fundamental cosm that we call our universe. There are cosms, there are verses, and relativity flips. Every cosm, relativity flips. These are fundamental understandings of the universe. These are actually hidden for a purpose or an accident. I don't know why, but the saying, "it's a matter of time," explains it. The very notion that the God particle is everything that the Big Bang is explains it. The micro mini novas we see, the micro mini black holes we see, the micro verse that we see in the Hadron Collider, which is a waste of time because there's no relativity. What they need to do is take two protons, throw them through the tube as fast as possible and collide them with each other and apply electrons at the same time. This way they can get fundamental reactions from the etherical plane, and a nuclear plane. So far they're just throwing neutrons down a thing and watch them explode. There's no relativity. All it is in a void. There's nothing there. They need static or they're not going to get anything. They need electrons. In the Hadron Collider, they need to collide protons in relativity with electrons. That's the only way they're going to get any kind of results. This way, they could see subatomic particles form just how we see them form in space on our cosm. This microcosm correlates with our unicosm, or nutricosm, which is our neutral universe that we know, and everything fundamental that we can measure in all of our fundamental physics. But when you get on a microcosm, the fundamental physics break down. You can't quantify them the same way. You have to break them up into fractional charges, fractional spins, fractional everything. Microfractional integers. Okay, these are microfractional integers. When you get on this scale, our fundamental math does not work the same way. We have to be able to transition our fundamental math as whole integers, half integers, quasi-integers, and even 16th or 8th integers. We're going to have to transition those into microfractional integers. Okay, we're going to have to find a way to do this. All right, unless they know how to do it, but they haven't related all these physics yet. These are the physics in the universe. I'm just trying to get this around. I'm afraid somebody's going to steal the theory and try to pass it off as their own. But my name is Jonathan Ulysses Marino Carr, and I'm the person that identified the God particle and how the universe works, how it came into existence, and the fact that the universe is static in only one plane of existence, and all the matter we see is what's expanding, not the universe itself. You cannot apply time to something that has no beginning and no end, because time is a measurement, and we can only measure matter. These are fundamental facts. The science either overlooks because they're overthinking, or these are fundamental facts that are suppressed, just like the God particle has been suppressed. So, I don't know if I'm doing the right thing or the wrong thing by unleashing this information to the world. But I'm afraid that if I don't, we're just going to keep on this dumb plane that we can't learn something. Now, this cognitive dissonance has to stop. We're going to have to open our eyes eventually and see the truth. And this is the truth, because we are not the center of the universe. We can see the center of the universe because of the Big Bang. We can look toward the center of the universe. But we are not the center of the universe. Okay? We have to understand that we are just tiny. We are fractional pieces of a universe. And there is a whole different cosm way bigger than us. Maybe even several cosms. Infinite cosms larger than us. And there are infinitesimally small cosms that keep transitioning smaller and smaller and smaller. So far, the smallest cosm that I can comprehend, that I can see in my head, because for some reason I understand particle physics and quantum mechanics. I think it has something to do, like I said, with this accident that affected my prefrontal cortex, okay? But my abstract thought is off the chart. And these cosms only exist, and there's relativity that flips inside out. All of this is the truth. The protocosm is basically the smallest that I can understand in my head so far. Now, I can actually keep breaking it down, but fundamentally, the protocosm is what comes first. Then there's a nanocosm. Then there's a microcosm. Then there's our unicosm. Then there's the macrocosm. So there are 5 cosms, but only 3 that we know of. The nano and protocosms are way too small for us yet to be able to identify. But we will. We will identify these very soon if we understand this stuff. The more we understand about the universe and the cosms and the connections, the more we will understand about everything we know. Everything we know. So I just want to get this to the world. And I want to get a little bit of credit, at least for my children. At least for my children.